All right, so Regents Chem here. Sorry, it's kind of late in the day here. About to eat dinner in a little while. Just couldn't get on here. My wife had a really busy day with her work, so I just got to this now. So I'm gonna go over the homework that was due today, the worksheet that was due today. And then I'm going to teach about gas solubility and Henry's law. And actually, I'm going to go over the homework, and then should have looked at my notes first. I want to show you a couple regents questions involving colligative properties. So maybe I'll do that in the next video. I keep them short and sweet, and it uploads better to YouTube anyway. Sometimes I lose videos. All right, here we go. So let's go with this color. Looks good. Won't match very well, but that's all right. All right, so let's see. How big is that? That's good enough. All right, so CaCl2 dissociates into Ca plus 2 plus 2Cl minus, so that's 3 moles of dissolved particles. 2 of those and 1 of those. Why? Because 2Cl is 1Ca. Na3PO4. I have 3 Na plus and 1 PO4 minus 3. So there's 4 moles of dissolved particles. 3 of those, 1 of those. 3 of those, 1 of those. And then this is covalent, so it actually doesn't dissociate. It stays together. It's just aqueous. Now these, I'm being lazy. These are aqueous. These are aqueous. These are aqueous. So when these dissociate, dissolve, break apart, remember, dissociate means specifically ions are breaking apart. So sugar, this is sugar, sucrose. This dissolves. These two also dissolve, but more specifically, they dissociate into ions, cations, anions. All right. Now this is only 1 mole. Kids are like, wait, there's so many numbers here, right? Because the way some kids learn colligative and they kind of memorize, they say, well, if there's more subscripts, that means there's more particles. That means higher boiling point. Add a solute, boiling point goes up. Add a solute, freezing point goes down. So lower freezing point, more particles, and that's what, I learned. That's good. However, it isn't about the subscripts completely. It's about, is it ionic or covalent? If it's ionic, it breaks apart. So automatically it has more particles, right? So if you have sugar here, even though there's a whole bunch of atoms, it's only really 1 particle, 1 mole of particles in the solution. Whereas this one only has 3 atoms, right? This has 12 plus 22 plus 11. This has 3 atoms, but because it's ionic and it breaks apart, dissociates, it actually produces 3 moles, 3 particles. So this has 1 big particle. All those atoms are bonded together. These are broken apart. So that's why it's 3, 4, and 1. Down here, you have 2 moles of particles. 1 Br minus and 1 Na plus, so that's 2 moles. So this one right here, letter B, has the greatest effect on the boiling point, freezing point, and vapor pressure. So like I said yesterday in the videos, add a solute, boiling point goes up. Add a solute, freezing point goes down. Vapor pressure also goes down. And I'm going to review that again quick here when I'm done. But this one here, letter B, would have the highest boiling point, lowest freezing point, lowest vapor pressure. So I'm going to zoom back out here and actually, here, I'm going to kill this and just do it again. All right, so we'll do it this way. All right, so let's just do it this way. All right. And all right, here we go. So we just said A had 3 moles, B had 4 moles, C had 1 mole, and D had 2 moles, right? Because colligative properties is dependent upon the number of particles, which is what moles are, right? We learned that a long time ago, 6.022 times 10 to the 23rd particles in 1 mole. Avogadro's number. So, long story short, it doesn't matter that A was calcium chloride and B is sodium phosphate and this is sugar and this is sodium bromide. That doesn't matter. It doesn't matter at all. It's how many particles are floating around in that water, in that solution. This one has 3 moles, 4, 1, and 2. So this one has the greatest number of particles. This one has the least number of particles. So Who has the lowest freezing point? The one with the most particles. So that would be B. So B would go there. Solution with the least number of dissolved. That would be C. It only has 1 mole versus 2, 3, and 4. Who does not dissociate? C. It's covalent. No ions. Or molecular, right? Molecular covalent, same thing. Lowest vapor pressure. Most particles. B. Ionic solution, which has the least effect. I didn't word that very well. Maybe smallest effect on the boiling point. So ionic solutions are this one, and this one. Those A, B, and D are ionic. Who has the smallest effect on the boiling point? It would be the one with the least number of dissolved particles. That would be letter D. NaBr is 2 moles, so that doesn't affect the boiling point as much as 3 and 4 moles. Highest boiling point, B. Solution that would melt ice at the quickest rate, B. You have more particles, more moles, it will lower that freezing point even more because there's more particles being dissolved and dissociating. Solution that takes the longest time to evaporate. Longest time would be B. If there's more particles, there's more forces. It doesn't allow particles to evaporate. Solution with 3 moles of dissolved particles, A. It has 1 Ca and 2 Cls. Solution that conducts electricity, ionic, right? A, B, and D. So that's A, B, D. Do not, C. That's old stuff. Hopefully you guys were good with that. Covalent, no ions, so no conduction. Ionic only conducts in solution or when it's melted because those ions are free to move. Now, this one here, melts ice. We put salt on the roads. Calcium chloride is the salt we use, and so is salt. Put them on the roads because they dissociate. They produce 3 moles and 2 moles of ions that lower the freezing point of water. So if you put this on the road and then it snows, the snow will actually melt when it hits this because once the snow, which is water, tries to dissolve and break this down, those forces of attraction start to form. And when that happens, that's the colligative property, the freezing point goes down. It has to be even colder for that to form crystals because of those forces of attraction and because the water is trying to dissociate, trying to dissolve it. So that's why we put salt on the roads. It lowers the freezing point. So instead of being 32, it has to be, 15 degrees to freeze, right? I mean, that's Fahrenheit. And regents chem, instead of 0 degrees Celsius for regular water, maybe it has to be -10 to freeze, right? So there's the answers. Hopefully that makes some sense here to you guys. Let me go back to this really quick. How much time do I have? 8 minutes here. All right. So again, add a solid. You know what? I'll just kill it here, and I'll come back with another video. I'll keep them short. All right.